Imagine a battlefield where the most dangerous sound is no sound at all. No missile launch, no explosion from a cannon, no smoke trail cutting across the sky. Just a beam of light, invisible or almost invisible, locked onto a drone for a few seconds. And then, the drone falls. For decades, laser weapons belonged to science fiction. They were the weapons of starships, supervillains, and future wars that always seemed far away. But today, that future is no longer far away. From the skies over Ukraine to the tense air defense networks of the Middle East, militaries are racing to solve one of the most difficult problems in modern war. How do you stop thousands of cheap drones, rockets, and missiles without bankrupting your own defense system? Because this is the brutal math of modern warfare. A small drone can cost a few $1,000s, sometimes less. But the missile used to shoot it down can cost hundreds of thousands, sometimes more. That means the attacker does not always need to win by destroying a target. They can win by forcing the defender to spend too much. This is where laser weapons enter the story. A laser weapon does not fire a bullet. It does not launch a missile. It fires concentrated energy. The basic idea sounds simple. A powerful beam is aimed at a target. The beam holds steady. Heat builds up. Sensors burn. Materials weaken. Wires fail. A wing surface breaks. A fuel tank ruptures. A drone loses control. But the reality is much harder. A military laser must find a fast-moving target, track it precisely, keep the beam focused, and deliver enough energy before the target escapes, turns, hides behind clouds, or reaches its destination. That is why real laser weapons are not like movie lasers. They do not slice tanks in half in 1 second. They do not turn the sky into a glowing battlefield. They are usually quiet, controlled, and highly technical. And that makes them even more interesting. Because the real promise of laser weapons is not destruction on a massive scale. It is efficiency. If a missile is like throwing an expensive spear, a laser is more like switching on an extremely powerful spotlight, but one that can burn through a drone's weak point. This is why countries are investing in systems like Israel's Iron Beam, Britain's DragonFire, and American high-energy laser programs. They are not trying to replace every missile tomorrow. They are trying to add a new layer of defense, a cheaper layer, a faster layer, a layer with a deep magazine, as long as there is enough power. In the wars of the 21st century, the sky is becoming crowded. Small drones observe artillery positions, kamikaze drones hunt vehicles, long-range drones strike oil facilities, power stations, radar systems, and cities. Missile salvos try to overwhelm air defense batteries. Ukraine has shown the world how rapidly cheap drones can change a battlefield. The Middle East has shown how rockets, drones, and missiles can arrive in large numbers from many directions. And in both cases, the same question keeps returning. Can traditional air defense keep up? Laser weapons may not be the complete answer, but they may become one of the most important answers. Not because they are magical, but because they attack the economics of war. For the first time, defenders may be able to shoot down certain threats for the cost of electricity instead of the cost of a missile. That does not mean lasers are perfect. Bad weather can weaken them. Dust, smoke, fog, and rain can scatter the beam. They need a clear line of sight. They need power. They need cooling, and they need time on target. A laser does not simply hit like a bullet. It has to stay on the target long enough to damage it. That means lasers are powerful in some situations and limited in others. Against a slow drone in clear weather, they may be extremely effective. Against a fast missile, heavy rain, or a target hidden behind terrain, they may struggle. This is why the future is not laser weapons replacing missiles. The future is layers. Radar detects the threat. Electronic warfare tries to jam it. A gun may engage it at short range. A missile may stop the most dangerous targets. And a laser may handle the cheap drones that would otherwise drain the defender's arsenal. This is the new air defense puzzle, and the reason laser weapons matter is simple. Modern war is becoming a battle of cost, speed, and endurance. The side that can defend longer, cheaper, and faster may survive the first wave, and the second, and the 100th. So when we ask whether laser weapons are finally real, the answer is not just yes. The better question is this: are we watching the beginning of a new era in warfare, where light itself becomes ammunition? To understand why laser weapons are suddenly so important, we have to look at the drone war. Ukraine is the clearest example. Since Russia's full-scale invasion, drones have become one of the defining weapons of the battlefield. Some drones are tiny, cheap, and flown by soldiers near the front line. Some carry cameras. Some carry explosives. Some fly deep into enemy territory. They are not always impressive individually, but in large numbers, they change everything. A cheap drone can force a tank to hide. It can expose artillery. It can guide a missile. It can make movement dangerous even far behind the front. And when attackers launch waves of drones, defenders face an impossible choice. Use expensive missiles and run out. Use guns and risk missing. Use jamming and hope the drone depends on a signal. Or find a new way to defeat cheap targets cheaply. This is where directed energy becomes attractive. In Ukraine, there have been reports, tests, and proposals around laser systems, including interest in Britain's DragonFire and local anti-drone laser concepts. But it is important to be precise. There is no public evidence that laser weapons have become a large-scale, decisive weapon in Ukraine. Not yet. What Ukraine has done is prove the need. It has shown the world that future armies must defend against thousands of drones, not dozens. And that has accelerated laser programs far beyond the laboratory. Britain's DragonFire is one of the most closely watched systems. It is designed as a laser-directed energy weapon that can engage aerial targets with extreme precision. British officials have said it could be fitted to Royal Navy destroyers from 2027, and that its operating cost per shot could be far lower than traditional missiles. That number matters, because the future of air defense is not only about whether you can shoot something down, it is about whether you can afford to keep shooting. Now look at the Middle East. Israel has spent decades building one of the world's most layered air defense networks: Iron Dome, David's Sling, Arrow, and other systems. But even advanced missile defense has a cost problem. Rockets, drones, and missiles can be launched in waves. Some are cheap, some are expensive, some are decoys, some are real threats. The defender must decide in seconds what to intercept. Israel's Iron Beam is designed to add a new layer to this system. It is a high-energy laser air defense system intended to intercept threats like drones, rockets, and mortars at short ranges. In recent conflicts involving Iran-backed groups, drones have created serious problems for traditional air defense. Some drones fly low, some are small, some are hard to track. Some can be guided in ways that make jamming less effective. Reports from the region suggest that laser systems have been tested or used in limited ways, including against drone threats. But here again, the key word is limited. Laser weapons are not yet a magic shield over an entire country. They need enough batteries, enough positions, enough power, and the right weather conditions. A single laser system cannot defend every city, every base, every road, and every border. But it can change the equation at a specific point: a military base, a ship, a power plant, an airport, a border area under drone attack. This is why lasers are especially interesting for fixed defense. If you know what you need to protect, and you can place sensors, power systems, and laser turrets around it, then a laser can become part of a strong defensive bubble. The same logic applies at sea. Ships have limited missile magazines. If a warship uses million-dollar missiles against cheap drones, it may survive the first wave, but become vulnerable later. A laser gives the ship another option, not for every threat, not in every condition, but for the right target, at the right range, in the right weather. It may save the expensive missile for something more dangerous. This is the real revolution, not a glowing beam destroying everything in sight. A quiet shift in battlefield economics. The attacker sends a cheap drone. The defender answers with electricity. If that works reliably, the balance changes. But there is another side to the story. Every new defense creates a new offense. If lasers become common, attackers will adapt. They may use reflective materials. They may spin drones to spread heat. They may fly through smoke, clouds, or bad weather. They may send larger swarms to overload the system. They may attack the laser's sensors, power supply, or cooling equipment. So the future will not be simple. Laser weapons will not end drone warfare. They will make drone warfare more complex. And that is exactly what happens with every major military technology. The tank did not end war. Radar did not end surprise. Missiles did not end aircraft. Drones did not end soldiers. They changed the rules. So what makes a laser weapon powerful? The answer is not just the beam. It is the system around the beam. A modern laser defense system needs radar to detect the threat, electro-optical sensors to identify it, software to track it, a turret to aim the beam, power systems to feed it, cooling systems to keep it from overheating, and operators who know when to fire. The laser is only the final step. This is why building laser weapons took so long. Scientists understood the physics decades ago, but turning that physics into a reliable battlefield system was much harder. You need enough power in a package that can move. You need optics that can survive heat, dust, vibration, and weather. You need tracking accurate enough to hold a beam on a small drone moving through the sky. And you need the system to work again and again, not just once in a test range. That is the difference between a demonstration and a weapon. A demonstration proves that something can happen. A weapon must work when the conditions are bad, the operator is tired, the target is moving, and the enemy is trying to stop you. This is where laser weapons still face serious limits. Weather is one of them. Fog, rain, dust, and smoke can weaken or scatter a laser beam. Clouds can block line of sight. Atmospheric turbulence can distort the beam over distance. Power is another limit. High-energy lasers need large amounts of electricity. That makes them easier to place on ships, bases, and vehicles with strong power systems. It makes them harder to use everywhere at once. Then there is time on target. A missile can explode near a target and damage it instantly. A laser usually needs to heat a specific point for several seconds. Those seconds matter. If the target is fast, spinning, shielded, or maneuvering, the engagement becomes harder. But despite these limits, militaries are still pushing forward. Why? Because the drone problem is not going away. In fact, it is growing. Drones are becoming cheaper, smarter, faster, and more numerous. Some are controlled by humans. Some follow programmed routes. Some use artificial intelligence to recognize targets. Some operate in groups. Traditional air defense was not built for a sky full of cheap machines. It was built for aircraft and missiles that were fewer, larger, and more expensive. Laser weapons are one attempt to rebuild air defense for this new sky. But the most realistic future is not a laser-only battlefield. It is a layered battlefield. Missiles for the fastest and most dangerous targets. Guns for close defense. Electronic warfare for drones that depend on signals. High-power microwaves for swarms. And lasers for precise, low-cost interception of selected threats. Each layer covers the weakness of another. That is how modern defense survives. For viewers, the rise of laser weapons can feel like science fiction becoming real. But for militaries, it is a practical response to a practical problem. Too many targets, too little time, too much cost. The question is not whether lasers will appear on the battlefield. They already are entering it. The question is how much they will matter. Will they remain specialized tools used to protect ships and bases? Or will they become common equipment mounted on vehicles, aircraft, and border defense systems? The answer depends on engineering, power, cooling, tracking, range, weather resistance, cost, production speed. The country that solves these problems first may gain a major advantage, but there is one final point. Laser weapons may look clean because they are quiet and precise, but they are still weapons. They will be used inside real conflicts with real risks, real uncertainty, and real consequences. That is why the conversation should not be only about technology. It should also be about strategy. If defense becomes cheaper, does that make countries safer? Or does it encourage longer conflicts? If drones become easier to shoot down, will attackers build more of them? If lasers protect military bases, will enemies target power grids and sensors instead? Every solution creates new questions, and laser weapons are no different. They are not the end of warfare. They are the next chapter in a very old contest. Offense versus defense, sword versus shield, drone versus beam, missile versus light. For now, the age of laser weapons is not fully here, but the door is open. And in Ukraine, in the Middle East, at sea, and around military bases across the world, that door is opening wider. The battlefield of the future may not glow like science fiction. It may look almost ordinary. A quiet container near a runway, a turret on a ship, a sensor watching the sky, a drone approaching in silence. Then, for a few seconds, invisible energy locks on. No thunder, no flash, no warning, just light becoming defense.